All right. Good morning, everybody. Good morning, everyone.
Good morning, sir.
Morning. I hope you didn't think that I deserted you. You know, our starting time is 9:15 to give everybody a chance to log in. All right. So I can see Aria, Keisha, Avian, Gabriel, Javari, Geneva, Empress, Natalia, Safani. Oh, hi, Shamir. You made it. And Ajir. You made it, Shamir. She's probably not near. All right. Morning, everybody. Welcome to our 6th marathon. We're doing good. I think we're doing good. And I hope you guys are keeping up. I'm not letting the videos pile up. Oh, that's good. It's good to know, Shamir. Nice to see you. Nice to meet you, by the way. All right. I hope everybody is keeping up to date, right? You know, the exam is only but 9 days away. Right. All right, now before we actually get into today's class, remember this week I'll be working with you. So starting tomorrow at 6 p.m. sharp, right? Please message me for the link. It's not any one of these links. Please message me for the link. Well, no, sorry, you don't have to. I'm gonna send it in the group. But for those who are not in my regular class groups, please direct message me for the link and you can access the class this week because, like I said, this week is free. And the purpose of me doing these free classes is to convert some of my 4s to 3s, right? That's the aim. I need to save at least 10 people per day. We need 40 people this week. 40 people who gave up and said, boy, I don't know if we can manage. I want to use these 4 days. I'm dedicating it these 4 days. I have no benefit gaining from it. So you must know, say, Marie did this, I try to do this because I want everybody to be on top peak, right? The objective of that particular class is to zone in and focus on one topic per day, right? 3 hours, we are work the same set of questions. Sorry, we're working different questions from the same topic. Now, when the message is sent out, you'll know what topic I'm going to do on which day. So lock in and, you know, just be there. All right, it's going to be good. I'm going to make, you know, my style already. You know, my energy one already. So I'm going to put a lot of effort and dedication into articulating what needs to be done for those type of questions. It's going to be probably about 8 years of questions. So 8 years of vectors, 8 years of statistics, 8 years of trigonometry, and 8 years of functions. All right, and we're going to, you know, we're gonna hit it hard, right? I want to make sure that whatever them send come on that paper on May 12th, whatever them send come, you guys will or you would have seen it already. The only thing that can stop you from getting it right is if you're nervous and you overthink and you just know, you know, you're not in control. But once you're in control and you're confident and you know that you're exposed, you have nothing to be apprehended about. All right. So that's the objective. So tomorrow, 6 p.m. I don't know what thing go. All right. Lovely. All right. Now for today, I am contemplating, guys. I'm contemplating working between 2021 and what other year. I'm not sure. I'm gonna pull up my screen and show you how I'm going. All right, because both papers have something important that I would love to really attack. So I'm contemplating between July 2021 and January 2021, right? So I'm gonna just do an initial thought, tell me if you do, and it's toward the 2021 paper. All right. So I'm gonna work this one up here. Okay, 2021 paper. So that's what we're gonna be doing today. All right. Lovely. And next week, Sunday, I'll be working the 2026 past paper. right? 2026 past paper. So the 2026 January paper is as close as we can possibly get to what Csec would have reset this into us, right? So once we can get somewhat close and we can have a good idea of what they sent a few months ago, this will give us a little bit of cushion. And I'm doing that just a few days before the exam. So that should be enough confidence for you guys to go in, all right, along with all of what we've done thus far. All right, so without any further ado, we're going to dive right on in. Hi, Zahenia. Good morning. Good morning, Zahenia.
Good morning, sir.
Okay. And Geneva. I don't see Antonia. Hold on. Let me see if these girls are in the waiting room. Hold on. Give me a second, guys. Let me balance this thing out. I don't see anybody. Good morning, Geneva. Good morning. So I don't see anybody in the waiting room. If there's anybody in the waiting room, please let me know so I can set them. All right, here we go, guys. Without further ado, let's dive into it. So now know what the plan be, right? Remember the plan, ladies and gentle folks, is to work the paper from the back to the front. But what you want to do is you want to attack question 1 and question 2 first and give yourself some level of control and confidence. Those are the two most doable questions on the paper. So you want to attack question 1 and question 2 and kind of, calm yourself down. Don't rush the paper by doing the paper directly from the back. There's no point in going to war and attacking the war from using heavy artillery. You don't want to, rush the vectors too much. You want to calm down, get yourself settled, get a couple questions right, build up your confidence, and then are you guys hearing me? Okay, you're hearing me. Okay, all right, good. All right, so you want to build up your confidence. So let's get into it then now. Right, so that's the front of the paper, right? When you go in the exam paper, as they're discussing or whatever they do, make sure you fill out your paper properly, right? Please, very, very important, fill out your paper properly. Read the instructions. All these instructions I've discussed with you already. And you have a formula sheet there. Not sure how useful that's going to be to most of you. All right, so here we go. So let's get some confidence in the brain and let's get into it. Okay. All right. So it says using a calculator or otherwise, you're to calculate the exact value of 1 4/7 divided by 2/3 minus 1 5/7. All right. So what we have here is two different operations working with. We have a division problem and we have a subtraction problem. Bear in mind that division and subtraction have different rules. Let us recall what those rules are. Once you're dividing, you're going to use the KFC method. That's the keep, flip, change. All right. So once you're doing division, you're going to do this part first here. And you're going to keep, change, flip. But before we keep, change, flip, let us convert. 7 times 1 is 7. Plus 4 is going to give us 11 over 4. Pardon me, guys. Give me a second. Let me just to get this meter. Okay. All right, so 717 plus 4 is going to give us 11 over 7. And then we have division by 2/3. And then we're going to have subtraction of conversion. 717 plus 5 is going to give us 12 over 7. All right. Now keep, change, flip. We're going to keep the first here. Keep the first here. We're going to change the sign here. And we're going to flip the last here. All right. And then we're going to have subtraction here. 12 over 7. I like to do everything in one line. Now, some students will work this part first, then that part first. No problem. That's your choice. All right. Now, in this case here, 11 over 7 and 3 over 2 have nothing in common. There's nothing in common here. 2 cannot go into 11, 3 cannot go into 7. We have prime numbers and odd numbers all over the place. So this is just going to simply be 33 over 14 minus 12 over 7. All right, 12 over 7. All right, so now we're at the subtraction section. We're going to go ahead and find the LCM. The LCM here of 14 and 7. Now, when I was teaching this, a lot of you guys would multiply the 14 times 7, and that will work, right? That will work. But you're going to end up with a big number than what you have to work with. So even though finding a multiple of 14 and 7 will work, you want to work with the smallest one. That's what I'm called the lowest common multiple. So in this case, if I multiply 7 times 14 and I end up with 98, you can still use 14. It's easier that way. 14 into itself goes one time up top here, and then 7 into 14 goes two times up top here. All right. So now we end up with 33 times 1 is 33, and 2 times 12 is going to give us 24. And when we subtract those, we're going to end up with 9, I believe, over 14. All right. Now, in the event that you do end up with an answer, let's say 14 over 9, my advice to you is do not leave your answer as 14 over 9. I'm not saying they're going to take off marks, but I'm not saying that they won't take off marks. All right. So we don't know what they're going to do or what they will do or who is marking your paper. So what you want to do is put yourself in a position where, regardless of what they decide to do, you won't be affected. All right. So I'm trusting that by now, everybody should be comfortable with fractions. We know the rules: add and subtract, find LCM, division, keep, change, flip, multiplication, we cancel. All right. Assuming that everybody here should be comfortable and A-okay. All right, moving on to the worded question now. When Megan started working, she was paid $85 each week. Now, we spoke about whenever we're reading questions that come across a bit convoluted, what you want to do is, as soon as you're reading through, you want to highlight certain things that pop out at you. So for me, as soon as I read this, I recognize that I need to pay attention to this thing right here. All right. So I need to pay attention to the fact that she was paid $85 each week. Now, after 6 months probation period, so I know that this is going to play a role here. This might play a role. 6 months. After a 6-month probational period, her pay was increased by 20%. How much was she paid each week after the increase? Each week. So we have to keep in mind that we're referring to here each week. All right. After, notice the word that they highlight, after the increase. So we know that she's paid $85 each week, but she got an increase of 20%. So therefore, we have two choices. We can either say 20 over 100 and times that by the current amount. Right, which is $85. And then when we get our result, we add it back to 85. So what's the result of 20 over 100 times 85? Where are my calculator girls in the chat?
17.
17, okay, 17. And then you'd add the 17 back to the 85, and then you'll simply end up here with $102. Somebody's mic is unmuted. Somebody's mic is unmuted, guys. Are you guys hearing me?
Yes, sir.
Yes. Just a minute, guys. Just a minute. I'm so sorry. Okay. All right, I'm back. Getting some. All right, you guys are seeing my screen, correct? You guys are seeing my screen?
Yes, sir.
Okay, lovely. Thank you. Sorry about that. All right, so 20 over 100 multiplied by 85. And so that gives us 17. And then we just, okay, let me just put a red marker around this. This is the answer. This here is the answer for when we worked out this here. 20 over 100 times 85. We add it back to the 85 to know what was the, how much was she paid. So how much was she paid? She was paid $102. Now we can, in addition, alternatively, we can simply add the 20 to 100 and get 120%. So we could say since the money increase from the original price of anything is 100%. So because there was an increase, you could say 120 over 100 and times it by 85. You should directly get the same answer as $102. Okay? All right. Lovely. Okay, let me check the chat to see if there's anybody here in the class that wants to come in. Miss Gentles, you're here?
Yes, sir. Could you tell me which past paper you're working on?
All right, good. Let's move on. Miss G, you there about?
Yes, sir. You're not
2021.
hearing
That's what we
me?
decided, guys. I think 22. I'm hearing you. I'm hearing you.
Okay. 2021?
I'm hearing you.
Sir,
I'm hearing you. I think so, yeah.
sir,
Yes.
you can scroll up back so I can get
Yes,
a
go ahead.
screenshot.
I'm
You
here.
can scroll up back so I can get a screenshot, please.
Okay, there you go.
Thank you.
Okay. All right, lovely. Moving right along. All right, now in 1965. Oh, is that the only question? Oh dear. Okay, that's it. All right, good. All right, so in 1965, the population of country A was 2,714,000. All right. In 2015, the population is now or was 3,663,900. Guys, could you please control your microphones? Thank you. Shamir, your microphone is unmuted. Thank you.
Okay.
All right, so in 14,000, and in 2015, the population was 3,663,900. Now, your task is to write the population in 2015 correct to three significant figures. You have to write the population that is in 2015 to three significant figures. So we now need to take this 3,663,900 to three significant figure. Now the question now is, what number represents or hold the position of my third significant digit? Is it the 3? Is it the 6? Is it the 6? Is it the 3, the 9, the 0, the 0? Which one do you think?
The 9, the 0, the 0.
The third digit that's not a 0. That's what you're saying? What's the third digit that is not a 0?
The 3.
The third
digit
that's not a 0?
9.
The third digit that's not a 0?
6.
Correct? The third digit? Don't do me that.
6, sir.
Yeah, man, the 6. How you get 9? Right, that's all. So that's where we want to board off the number. Now we're going to check the number that comes after right here. And that number is less than 5, so we can just simply ignore these or just replace them with a 0. Not or, replace them with a 0. So if the number that comes after that line is less than 5, you can just replace all of those with a 0. So the answer then is going to simply be 3,660,000. Replace it with a 0. Replace that with a 0, and that with a 0, and that with a 0. So the answer is 3,660,000. Okay.
So that was what I was thinking. Even though I said it's 3, I think that I was thinking that that's where it would start.
Okay, no problem. All right, now we're to write the population that was in 1965 in standard form. All right. So these are some cheeky little 1 marks that many students will inadvertently give away, but we don't want to give these away. These are the marks that we want to really put in the bag. Remember that we have a bag that we need to fill up with 60 points. And we have a bag where we know so we can take some waste points and throw it away, right? Because the questions are a bit too tough in that moment. So remember, don't take too much of the points that belong in the bag of 60 and throw them into the bag of 40. You want to make sure that your winning bag, has more points than your losing bag. All right, so stuff like these, you want to make certain that you don't forget them. Now, how do we convert the number, the population, which is this here? How do we convert 2,714,000 in standard form? Please remember this, guys. When you are when you're going to be writing a number in standard form, the objective is to bring the point, the objective is to bring the point between the first 2 digits that is not a 0. All right? So in this case, you might be asking, sir, I don't see a point. There is a point. The point is going to be at the end because this is a whole number. So we need to bring that point here, that red point right there. Watch me now, jump. 1, 2, 3, 4, 5, 6. The new point must be between the 2 and the 7. So once I bring my point there, I'm going to say 2.714. All right. I'm going to times that by 10 because standard form is times 10. So it's 2.714 times 10. No, it needs to be raised to a power. Now the power that you to the 6, 1, 2, 3, 4, 5, to the 6. But be mindful of what kind of 6 is it. Is it positive 6 or negative 6? When we jump to the left, so it is positive 6, correct, Geneva? So it's positive 6. All right, so if you jump to the right, it's negative. If you jump to the left, it's positive. For those of you who are about to ask me, sir, but when I'm on the number line, knowing to the left is negative, remember that standard form works opposite to what the number line tells you. All right? All right, so make sure you remember that, okay? So lock that in. It's a free 1 mark. Take it and go. All right, now, we now need to determine the percentage increase. So we need to determine the percentage increase in the population from 1965 to 2015. Now, for us to calculate the percentage increase, we need to know what is increase. We can't calculate the percentage of something if we don't know what it is. So first we need to know what is the pop increase. So the population increase would be to subtract. So the pop increase is going to be, 3,663,000 minus 2,714,000. Oh, this is 900. Okay, sorry. It's 900 right here. All right, I'm going to minus 2,714,000 from this. Somebody go ahead and do that subtraction for me quickly. And what is that calculation, guys? I'm not hearing anybody. And if you're answering, I'm not hearing you.
949,900.
949,000. Talk to me now, guys.
Yeah,
Oh, yes.
949,900.
949,900. Sorry, Geneva, I was looking in the chat. 949,900. All right, so that was the increase, not true. So we want to
I got 919,000.
919,000. All right, guys, now double check that. We can't be using the calculator and getting this wrong. So type in the numbers correctly, please, and confirm it.
Oh,
It's correct, sir.
I think he may be right.
Okay, he's right. All right. No problem. All right, so always do that. Always double check. Nothing wrong with double check. It's okay. Mistakes are inevitable. All right. So 949,900. Lovely. Now we need to convert that percentage increase. So we need to say 949,900 and divide it by the original population, which is 2,714,000. And because we want the percentage, we're going to times it by 100. So remember that when you're comparing an increase, you don't compare the increase to what it is, you compare the increase to what it was. So we know that there was an increase of 949,900 in the population, right? We have to compare that to what it was before it reached 3 million. All right, when we do that math, tell me what percentage you get.
35.
35%. All right, good. And that's it. All right. So some nice little 1 mark and 2 mark thrown all over the place here. You just want to grab these and move right along. All right. All right. Good. Good. All right. Moving right along to the ratio. Right. I see students make a big deal of ratio all the time. And as you can see, it doesn't come with any heavy marks. For some reason, I just don't. Well, for me, I have to speak from a teacher's point of view. From a student's point of view, though, I don't know if ratio is like a plague for students, but usually whenever I ask a student, give me a question that you'd want us to review, they'll say to me, sir, I don't understand ratio. The question that is worth the least on the paper is what students would like to practice. People don't do that. All right? These questions are questions where you can either it's either you get it right or you get it wrong. When you want to practice, questions that carry heavy marks. Those are what you want to practice. Like I'm scrolling on TikTok and I've seen a lot of instructors and what they're teaching the students. Okay, let's move right along. Let's not talk about that today. All right. The ratio of teachers to male students, we're going to use T to represent teachers. To male students, we're going to use M for male. To female students, we're going to use F for female. So what do you notice that I did there? I know that they're comparing 3 things. They're comparing teachers to male students to female students. Those are the 3 ratios. That's 3 comparisons. And how did I know that they're comparing 3 things? I'm seeing the 3 things right here. So do you notice what I did? What I've done here is that I've just used the initial to create a ratio. T to M to F. And the ratio is 3 to 17 to 18. So 3 to 17 to 18. Let us discuss what this means. It means that for every 3 teachers, there is 17 males in the classroom and 18 females in the classroom. That's what the ratio is saying. So 3 teachers is responsible for 17 males and 18 females. All right? Now, moving right along. If the total number of students in school is 630, determine the number of teachers in the school. All right? So we know that the total amount of persons or total students in the school is 630. What we need to do, guys, is to add these things here. So we're going to find the total proportion. Total proportion meaning the total that the entire school has been divided into. So we know that the school has been divided into, hold on, give me a second here. Wait, hold on. No, this time no, hold on, we can't do that. We can't do it that way. Because they want the amount of teachers. We already know that for every 3 teacher, hold on, give me a sec, guys. I have to improvise a bit here. So for every 3 teacher, we know that they are responsible for 17 and 18. So let's add these two together instead. If improvise. What is 17 plus 18, guys?
35.
35. So there's 35. So 3 teachers is responsible for 35 students. Not true? So for every 35 students with 17 males and 18 females, 3 teachers is responsible for them. Let us divide the total school population by 35. So we have 630 divided by 35. And that will tell us the amount of teachers that is needed in the school.
18.
Pardon me?
18.
18 teachers. And that's it. So a simple improvisation there. Now, just in case you guys are probably asking, sir, why didn't you add the 3 to this? Because we are told that the population of students is 630. We weren't told that the population of students and teachers is 630. So we have to exclude the 3 from the sum because the information that we got was in relationship to students and not student and teacher, right? So if they had said something like the total population of students and teachers in the school is 630, then I would have to add 3 to 17 to 18 and then divide it into that. However, that's not the case. Yes.
What if we were asked if to determine the amount of male students or the number of female students?
But we were already told that information right here. Oh, in the school?
In total.
In the school.
In the 630.
In the 630. All right. So
yes.
that's actually a very, very good question. So if we were asked to find the number of male students, let me see here. All right, so let me see. I think we'd have to divide. So there's 17 males for every 3 teachers. So I guess
divide the 630 by 17?
Yeah, that's what I'm thinking. I'm thinking that we'd have to divide the 17 into 630. No, that don't make no sense neither.
We get a decimal.
Yeah, that would make no sense. Let me see. All right. Give me a second here. Let me measure. That's a very good question, you know. So they wanted to know how much is here. Let me see. So naturally we'd have to add the 17 and the 10. I think this number would have to. So this is what? This is the amount of students that is in the school. 17 to 18. 18 times 3. You know, say, I think now that you asked that question though, I need to review this last answer here. This 18 here. So this 35 students here divides into the 630 gives us 18. You don't think, I think we need to multiply this thing here by 3, you know. Because for every 35 students, you know, I open our minds to me, I say, guys, for every 35 students, right? 3 teachers is needed, not true? And there is 18 groups of 35. And for every group of 35, so guys, we need to multiply this 18 by 3. It's 54 teachers needed. My God. How did that pass me? The first question, guys, is when we added the 17 and the 18, and we got 35, for every 35 groups of students, we need 3 teachers. And so how many groups of 35 can we get from 630? We calculated 18 groups of 35. But because for every group of 35 needs 3 teachers and there's 18 groups of 35, it is 18 times 3, 54 teachers is needed. So, yeah, guys. So for the question 1 right there, thanks for the question that you asked. It highlighted that we left off. So we would have only gotten 1 mark on the exam if I had left it at 18. Yeah. Do me a favor. Can you multiply 18 times 17 for me and tell me what you get? 18. I'm trying to see if I can figure out how to answer your question about the male students.
206.
306.
306. And then multiply 18 by 18 for me, please.
324.
324.
324. And when we add these two, do we get back did we get back 630? We should.
Yes.
Good. So to answer your question that you asked me earlier, and that was such a good question, you know. This really is a good question. Right? So to answer the question you asked me, what if they wanted to know how much male students is in the class? When we add the 17 and the 18 and we get 35, after dividing the 630 by 35, we'd multiply the 18 by the amount of males that are currently in the ratio. And it would tell us how much males are in the school. So we'd have had 306 males and 324 females.
Okay.
Yeah, man. Very good question. Really, really good question. All right. So hopefully I didn't confuse anybody a while ago, right? Mistakes do happen. Sometimes we overlook certain things. All right. So if she hadn't asked that question a while ago, I probably would have gone in the exam and probably would have just left the answer at 18. So good question. All right, moving on. All right, 2 quantities N and T are related as follows. So this is the relationship between N and T. N is equal to the square root of T. Now, we are told to find N when the value of T will be, when T will be replaced by 49. So that's very straightforward. N is going to be equal to the square root of what them say T is, which is 49. And if you go on your calculator and you check that out, N works nicely to be 7. Very straightforward. Very, very straightforward. Give me a second, guys. 1 minute. All right, now make T the subject of the formula. Make T the subject of the formula. Meaning that from N equals the square root of T, we need to get T to be all by itself. And at the moment right now, T is covered by a square root. Now we already know that to remove a square root, we will have to square both sides, correct? All right, so we can go ahead now and say, I'm going to square the N. Hold on, let me just go ahead and use different colors. So I'm going to say N, I'm going to square the N, and I'm going to say equal to the square root of T, and I'm going to also square this side here. So by squaring both sides, the square root will be cancelled by the square. I'm going to be left with T, and then of course N squared. We don't know what N is, so we can't square it. So the answer is just N squared, and that's it. N squared is equal to T. That's it. That is it. All right, moving right along. Ali is X years. Ali is X years, as in X years old. Jim is 5 years older than Ali. And Chris is twice as old as Ali. Let's read it again. Ali is X years old, right? Jim is 5 years older than Ali. And then Chris is going to be twice Ali's age. So whatever age we get here, whatever age is out here, Chris is going to be twice that age. And we already know that since Jim is older than Ali by 5 years, it's connected to this right here. All right. Question. Write an expression in terms of X for Jim's age and Chris's age. No, I'm just talking to the class generally. If I'm 30 years old, pardon me. If you're 20 years old and I'm 5 years older than you, how old am I?
$25.
How did you get the 25? What did you do mathematically?
Add the
25.
5 to 20.
Yeah, add the 5 to the current age, not true?
Yes.
Good. So if Ali is X years old now, and Jim is 5 years older, how old is Jim right now?
X plus 5.
And that's it. That's it. That's it. Now go to the blue one now. Chris is twice as old as Ali. How old is Ali right now?
X.
And Chris is twice as old. So it's just times 2, which is just 2x. And that's it. That's it, ladies and gentlemen. Gentle folks. Moving right along, since there's no questions. Now, this is the tricky bit. Tricky bit meaning not hard, but tricky bit. In 2 years' time, the product, keyword here, product, which means to multiply, the product of Ali's age, and Chris's age. What is Ali's age? Ali's age currently right now is X. And Chris's age right now is 2X right now. As we speak right now, Ali is X years old and Chris is twice his age. And in 2 years, when you multiply them age, it's going to be the same as the square of Jim's age. This confuses many students. So we're going to talk about this question. We're going to reason it out and make sure everybody understands the reasoning behind it. What I've found out that when we present students with questions like these, right? The assumption when a student says that someone is twice their age or in 2 years' time, the temptation is to multiply. Listen, if you are 20 and I'm 25, how old will you and I be in 2 years' time? Think about it, not mathematically, but logically. You're 20 and I am
24 and 27.
25. Yeah. So if I'm right, correct. If I'm 20, if you're 20 and I am 25, in 2 years' time, you'd have to add 2 to your age and 2 to my age, not true?
Mm-hmm.
So as it relates to a student saying that in 2 years' time, you're going to multiply by 2, you can't say in 2 years' time, you're going to be 40 and you're going to be 40 and I'm going to be 54. That makes no sense, right? So the part here where students assume that you have to multiply is just a fundamental problem. It's not the difficulty of the math. It's just a fundamental understanding of the question. So right now, right, Ali is X years old. In 2 years' time, Ali will be X plus 2. Because in 2 years, I'm going to add on 2 upon him age, right? 2 years from the age. So Ali is X right now. So in 2 years, Ali is going to be X plus 2. And meaning Chris' age is now 2X at the moment. And in 2 years, Chris' age is also going to be increased by 2. And the key word here is product, which means to multiply. So when I take Ali's age and I multiply it by Chris's age, then they're saying that is going to be equal to the what? Square of Jim's age. But Jim's age at the moment is X plus 5. So when I take Jim's age and I square it, then that's my equation. All right? Make sure everybody understand that before I move on. And if you want to go back over it, I can. Everybody clear on the reasoning? Because when I started the maths, you know, are we clear on the reasoning?
Yes, sir.
All right, so this is good. I'm not seeing nobody in the chat. Everybody else who's in the class, no good, Shamir? You're okay with the reasoning?
Yes, so far.
So far. Okay, good. All right, so I'm assuming that everybody else who is silent is good. All right, good. So now, we need to show that the equation that has been created will simplify down to this. Right, so they say show that the equation x squared minus 4x minus 21 equals 0 represents the information above. So how do we get this thing that we have on the screen here down to that? We know that when two brackets are joined together, we have to use the foiling technique. And the foiling technique is where we take the first term and multiply the what? Outer terms. Then we take the inner term to multiply the last terms. So that's the FOIL method, foiling. Yes, question.
Somebody in the chat is asking you to go over it because their mic isn't working.
Go back over. Yeah, I'm seeing Kedra asking go back over it. As in you I should go back over it like from what part? Where are you? Where did I lose you? That's what I want to know. Have I lost yet? Where I added the 2, where I get the 2 from? Is that where I lost you? All right, I'll just move on because I'm not sure if her mic is working or not. All right, so anyways, x times 2x is going to give us 2x squared. X times 2. So watch now, watch the arrows now. X times 2x is 2x squared. X times 2 is 2x. 2 times 2x is 4x. And 2 times 2 gives us 4. Now the x plus 5 now. So hold on, guys. You see, for the x plus 5 here, I'm going to go to the side and work that out. X plus 5 squared is really saying, hold on, do not square the x and square the 5, you know. You're going to say x plus 5 squared is x plus 5 times x plus 5. And then again, you're going to do the foiling technique on this one. X times x, x squared. X times 5, 5x. 5 times x, 5x. 5 times 5, 25. Simplify that down. We're going to get x squared plus 10x plus 25. All right? So when you break down the square of Jim's age, you get this thing over here. All right? Now, let's go back to our original calculation. This here was just a side calculation for squaring Jim's age over here. So let's go back to the original now. When we multiplied Ali's age times Chris's age, we got this thing down here. 2x squared, break it down nice and neat, plus 6x plus 4 And that's going to be equal then to the thing that we have over here, x squared plus 10x plus 25. So breaking this down nice and neat, put all the squares together on, well, sorry, transfer everything on the left side. So breaking it down, we're going to have 2x squared, carry this x squared to come over here, minus x squared. Then we're going to have plus 6x. And then bring this 10x over here, we're going to get negative 10x. And then write down back the plus 4. And we're going to bring this 25 over here, minus 25. When we simplify that nice and neat, we get x squared. 6x minus 10x is negative 4x. And then 4 minus 25 is minus 21. And because you transfer everything on the left, everything is now equal to 0. And that's exactly what we have here. Okay? So it looks like a tough question. And for some, it may be. But the analysis of the question is where the setup comes from. So all of what we're doing here are stuff that would have been taught to you by me or by some other teacher about how to FOIL. But the setup of the equations is where the challenge might come in. All right, and just to reiterate, I'm seeing your comment, Kedra, where we were saying something about the ages. Also, you're asking about Ali's and Chris's age. So with the part that says, Kedra, 2 years time, the assumption that students make is to multiply by 2. The analysis is that if I'm 20 and you're 25, in 2 years time, you would be 22 and I would be 27. So as opposed to multiplying by 2, you're going to add 2 to both of our ages. So you see the 2 we add to the x here and this 2 here, we added it to Ali's age, which is currently x. So we add 2 to x and we add 2 to Chris's age right here. That's why we got the x plus 2 and the 2x plus 2. And then we simplified it and get it down to that. Okay, but if not, just watch back the recording of that section and then you'll get a bit more clarity. Okay, all right, trusting that everybody's okay thus far. Okay, all right, everybody's good. Now the next question says we should calculate Ali's present age. So because Ali's age is x right here, basically what they're trying to say to you is to find the value of x. That's what they're trying to say. So to find the value of x, we need to solve this equation. X squared minus 4x minus 21 equals 0. Does anybody remember or know what type of equation this is?
Quadratic.
It is quadratic equation, you're correct. So I'm sure that we all know that we're going to multiply the first times the last, right? You could use the quadratic form, but that takes too long. So first times the last, which in this case is 1 times 21. And as usual, like I said, guys, if you know what the factors are, don't waste time like me doing 1 times 21 and doing all that stuff. If you know the answer is 7 and 3, get to work. But for me, I'm going to list them up because I'm teaching. So 1 and 21 should give me 21. And 7 and 3 should give me 21. And it so happens that 7 times 3 is 21. And negative 7 plus 3 is also negative 4. So I got my factors, negative 7 and plus 3. So we're going to end up then with x squared, right? We're going to replace the middle term with the factors that we have selected right here. So x squared comes back down right here. And then we're going to replace the negative 4x with negative 7x. Sorry, with positive 4x and negative 7x. The order of which you put them doesn't matter. The order in how you put them doesn't matter. But like I was telling the students yesterday, when I'm placing my numbers in a particular order, I'm placing them based on making my factoring easy. So why I put the 7 beside the 21 is because the 7 and 21 is clear. All right? It's easier. Doesn't matter which one you're doing, you're going to find the factor number. It's just easier for me mentally. Now, here we're going to make this equal to 0. Don't forget to make it equal to 0. Bracket here. Bracket there. Common factor in the first bracket is x. X into x squared goes x times. X into 4x goes 4 times.
Sir,
yes.
For the part where you miss out the 3, you put 4x
Oh, it's
instead
3.
of 3. Yeah.
Oh, respect. Thank you so much. So this is supposed to be 3, not 4. All right, thank you so much. So it's x squared plus 3, not 4. Thank you so much, sir. All right, so this is supposed to be corrected right here. So it is going to be x open bracket x plus 3. Thank you. And that's going to be minus 7 open bracket x plus 3 as well equals 0. All right, so it so happens now that the common factors are x plus 3 and the other factor is just simply x minus 7 equals 0. Now, can anybody tell me which of those brackets would contain the correct answer? Both brackets are not correct. Only one is the right answer. Which one do you think is the right answer and why do you think so?
X plus 3,
You're saying that's the right answer or the wrong one?
the right.
All right, let us see. So you're
So
saying that
for me, it would have been x7, 7x, because the x plus 3 bracket would have cancelled out the other x plus 3 bracket. So that only left with the x negative 7.
all right, so your answer is right, but your reasoning is incorrect, right? About the canceling. So your answer is right. For you, you'd say x plus minus. So you'd eventually get the answer right anyways, right? But your reasoning behind why you think it's not the right answer is slightly off. The reason why x plus 3 is not the right answer is because age cannot be negative. So there's no way that you could say that Ali is negative 3 years old. So that's the reason why. But if you take x minus 7 and make it equal to 0.
So it is x plus 3 and x minus 7.
Yes, that's the answer.
Okay.
X plus 3 in the bracket and x minus 7. So x minus 7 over here, x must be equal to 7. So this would have to be the right answer because age has to be positive. All right. So yes, Suj, you would have chosen the correct bracket and you would have gotten to your answer, but you would have left the exam with an incorrect reasoning. But I hope I gave you some clarity on that. Everybody okay?
Yes.
All right. All right, moving on. So now you realize that now we would have taken just because the explanation why I'm taking an hour to explain this. If I was doing this, I would have finished this in 30 minutes. Right? And that's what's gonna happen. But the explanation and the reasoning is what I use my marathons for. Right? So other marathons online, when if you're watching any past people, if you notice how fast they move, because you're teaching from their base, they're not talking to people live. When you're working on past paper with person that are interacting with you and having questions, you have to make sure say you go through the crevice and the nooks and the crooks and make sure say people clear on what to do or what not to do and how to think and what not to think. All right. So that's why we may be moving this slow, but I hope you're getting clarity. All right, so we're gonna move on nicely then to the next question here. The diagram below shows the triangle PQR in which the angle QPR is 62, which you can very clearly see the angle right here, 62, and the angle PQR is 90. You can see the box clearly right there, that's the 90. The box represents the 90. And PR is 11, which you can clearly see right here, the 11. All right? Now, your next question here is to calculate the angle PRQ. Now, let me pause for a second to remind, because every day I have new students or students who probably sleep off in my class, or students who probably just hear but they don't really listen to the concept. When an angle is named with 3 letters, let me reiterate. When an angle is named with 3 letters, the position or the location of the angle is at the letter that is in the middle. When an angle is named with 3 letters, the position or the location of that angle is located at the letter that is in the middle. And the angle's location must be created by the line P and the line Q. So notice that the line P and the line Q, both of those lines intersect at R. So that's the angle that they're looking for. All right? Now, angle in a triangle, correct, my boss. Angle in a triangle measures what? 180. So therefore, I see you, Javari. I see you. Can use that method as well. I'm going to explain it shortly. So because we know that angles in a triangle measure 180, we can simply say that 180, which is for the entire triangle, for the entire angles in the triangle, I'm going to minus the sum of 62 degrees and the 90 degrees in the corner there. So we'd end up with 180 minus 152, which works out nicely to be 28 degrees. Now, if you check the chat, you'll see a young man in the comments saying that he could have gotten the answer by saying angle PRQ is equal to 90 minus 62, and he would have still gotten the same answer as 28. So as to why did he do it this way, I think it was a concept I showed him in class. You see, because this angle right here, so ladies and gentlemen, is already 90. You see, because we know that the complete angle in the triangle is already 180, and we already have half of it already, and we know that half of it is 90. These two here cannot go past 90. So therefore, taking 62 from 90 is just, I guess it's just another way of thinking about it, right? This is just what you call the complementary method. So you use the complementary reasoning to do it that way, but this is the more traditional way that most students will work it out when they know that all angles in a triangle measure 180. So just add up and take from 180, good to go. So anyone, it won't make you any brighter than the other person. All right, it's just your way of thinking. All right, so good job, Javari. Good job. All right, next one says the length of the side RQ. So remember now, ladies and gentlemen, that we are on. Let me just clean my diagram up, please. All right, so this is just a bunch of explanation here. Keep my diagram clean. All right, so here what we have now is the length of RQ. Remember that we are on a right angle triangle. So keep everything intact, guys. Right angle triangle requires either Pythagoras theorem or trig ratio. Catch your Javari, not cosine rule. Cosine rule and sine rule is used in triangles that are non-right angle. So get that together. Don't mix it up. All right. And even if you could have used the cosine rule, you don't have the two sides and the angle between. Yeah, man. Sort it out, my boss. Sort it out. So for this year,
A square plus B square equals C square.
you could in that case, Pythagoras, you'd need two sides, Shamir. You don't have two sides.
Okay.
So you'd have to use one of the trig ratios, the sine, cos, and tan. One of them.
So it would have been the sine rule, because
Let's see. Tell us what.
the adjacent. No.
What side do you have?
The adjacent.
What side do you have?
The opposite and the hypotenuse.
The
So the opposite would have been the 11 centimeter.
No, the opposite would have been the hypotenuse.
Oh,
sorry.
okay.
The hypotenuse would have been the 11, and the opposite would have been the side you're looking for. Because RQ is in front of the angle, so that's the opposite. And the 11 is in front of the 90 degrees, so that's the hypotenuse. So it would have been the sine. All right. So ladies, let's just take up, ladies and gentlemen, folks, let's put it all together now. All right. been through this a couple of times, but we now start go back over it until it stick. When it comes to trigonometry, there are two categories. There's two sections. Trigonometry is divided up into two sections. You have the section that focuses on right angle triangle, and you have the section that focuses on non-right angle triangle. Let's go through this one more time. When it comes to a right angle triangle, regardless of where you see this shape, once you see this right angle triangle, best believe it's either going to be trig ratios, which is the sine, cosine, and tangent, or it's going to be Pythagoras theorem that will combine to assist you in solving what you're trying to solve. When it comes to a triangle that does not have this box right here, then it's going to be cosine rule or sine rule. So remember, guys, you need to take a moment and, run it back through your head. Say it again and again. Over here, so, right angle triangle deals with Pythagoras theorem and trig ratios, and over there, so, deals with cosine and sine rule. Make sure you know which triangle you look on and which formula can be of assistance to you with that particular triangle. All right? Good. So we agree that we're going to use the sine. So now we're going to go ahead and say sine of theta is equal to, and if you look on your formula sheet, you'll see it up there on the formula sheet, opposite over hype. All right, so in this case now, the sine of the angle, the only angle you have is 62, and the opposite side is going to be, as you look on the diagram, the opposite side is the side that you're looking for, which is RQ. And the adjacent, and the hypotenuse side, pardon me guys, the hypotenuse side is 11. Now, when the unknown is at the top, when the unknown is at the, when the unknown is at the top, so our unknown variable is at the top, what do we do when the unknown is at the top?
Swap.
Correct. Swap when it's at the bottom. You cross multiply when it's at the top. Write that down, Javari, so you don't mix it up. So you're going to go ahead and say RQ is equal to 11 multiplied by the sine of 62. So remember, simple things, very simple stuff. These little shortcuts that I'm showing you, these simple things will make you get an inaccurate answer. Yes, you're demonstrating on paper that you know what needs to be done, but you still need to compute correctly, because too much incorrect computation will give you a C or a D. So you may get an A for understanding, you may get a A for knowledge, you may get a A or a B for comprehension, and because you get a D for computation, them slam you with a 4. Yeah, man. I say thing go down, say thing come down. So be very, very careful with your computation. Where would I lean towards? I will lean more towards my computing skills. I need to make sure that my computation gets at least bare minimum a B. I'll take a C for comprehension, and I'll take a B, and I'll take a grade 2 and go on with that. But if everything you work out wrong, but you understand what needs to be done, you have a serious problem in math. All right? Because at the end of the day, what people are looking for is the answer. All right? All right, so make sure you take note of that. What is the answer for RQ now, people?
Sir, I get 9.7. 9.71.
9.74?
9.71.
9.71. 9.71. Okay, all right, give me a second, guys.
Let me get 9.6168.
All right, just a minute, guys. I'm still here, guys. Just give me a minute here. I'm gonna let somebody in. My apologies, guys. So sorry about that. There's some students that are trying to get in, but they didn't contact me about the link. All right, so where are we? I saw somebody said something about 9.71. That's what you got? Okay, that's it. All right, Shamir, your microphone is unmuted there. Thank you.
You want me to mute it?
Oh yeah, no, mute it whenever. No, as you're going to speak, you can open the microphone, but as soon as you're not speaking, just close it. Fair enough. All right, thank you.
Okay.
All right, good. All right, so back to programming now, guys. Back to regular programming. All right, so that's it. So that's question. Is that question 3? That's it? Oh no. Okay, so question 3 continues. Okay, so question 3 is trigon transformation. All right. So the diagram below shows 3 triangles, X, Y, and Z, which you can very clearly see right here. This is triangle X, this is triangle Y, and this is triangle Z. All right, so you can see them very clearly there. So there's nothing really up here for us to worry about. There's no information given, so we can just move right along to what they're asking us down here. So it says here that triangle X is mapped onto triangle Y by a reflection. You're lucky them even tell you. They're telling you that X maps onto triangle Y by a reflection. I'm expecting them to ask you what it is, but they're telling you. Now them say state the equation of the mirror line. And I'm so happy that these questions are coming up. The reason why, because there's so many ways how Csec asks the questions and throws off my students. So when these questions are coming up, I'm happy. So X maps onto Y by a reflection. X maps onto Y by a reflection. So that means if it's a reflection, ladies and gentlemen, that means that the distance from the points are the same. All right, the distance from the mirror line is the same. So what do we mean by that? Watch me now, guys. This corresponds with, hold on, let me use a different color. So this point corresponds with this point. This point corresponds with that point. And this point down here corresponds with this one up here. All right, now the question is, what is the distance between this come down here? What is the distance between those two? Distance in terms of units. What is the distance between this
90.
point and this point? 90 distance, 90. Them box here, 90. Are you sure?
4.
4. 4 squares. The distance between them, not angle. Distance between them is 4. Now what is half of 4?
2.
2. So that means say the mirror line has to be located 2 units below and 2 units above and 2 units below. So the mirror line basically is this line right here. So the mirror line is the what? X-axis. So basically then, this is just a reverse way of asking the question, right? As opposed to telling you that X and Y is a reflection across the X-axis, they give you the X, they give you the Y, and tell you it's a reflection, and then ask you from which line has it been reflected through. Now the X-axis has an equation, and as tough as it may sound, the equation of the X-axis is Y equals 0. So the jot this down, guys. So the X-axis equation, in case you see it anywhere else, the X-axis equation is Y equals 0, and the Y-axis equation is X equals 0. It's just the opposite. So the equation of the X-axis is Y equals 0, and the equation of the y-axis is x equals 0. All right, so make a note of that in case I ask you that. All right. Okay. Now it says that we should describe fully the transformation that causes x to map onto z. And I saw Javari mention something earlier. X onto z. You're correct.
Hold on. So
Yes.
that's the answer, x equals 0 and y equals 0?
No. This is information. The answer is y equals 0.
Oh.
No, this is just me teaching. This is just me giving you added information in case them reverse it by you.
Okay.
All right, good. So the answer is x y equals 0.
Okay.
All right, good. So now they said describe fully the transformation which maps x onto z. Javari, you want to tell them why you thought it was rotation, or you were just guessing? Which one?
No, man, that's a rotation because you can see where the angle did not enlarge. Right, so you can see where it maps 90 degrees to x from y to x and another 90 from x to z.
Okay, so that's
each quadrant is 90.
Okay, all right. I like the reasoning there. All right, I'm not sure if that gives anybody in the class clarity though. But if I hear reasoning, no problem. All right, so he's saying that x onto z is a rotation of 90. By a process of elimination, number one, it can't be an enlargement because the object nor the image did not get bigger, so we can eliminate that. It can't be a translation simply because the object and image are not identical. So x and z are not identical in appearance. So it's not translation. It is not a reflection because we already have a reflection. And if it's a reflection, they're supposed to look back to back or them look opposite. So by process of elimination, it's not enlargement because it don't get big or small. It's not a translation because them don't identical. And it's not a reflection because we already have a reflection. So it's a rotation. And as Javari rightly said, that each quadrant is a 90 degree. So if it moves from one quadrant to the next, then it's 90. All right? Now the description is what? So now that the analysis is out of the way, what's the description? So we need to state, in the description, we need to write a statement, a sentence, or a description. In the English language, you know what a description is. In the description, we should state type of transformation. So it's 2 marks. Type of transformation. And we need to state the angle of the transformation. So we need to state the type of transformation and the angle of transformation. So write this down for me, guys, please. When you're describing this is what you see. Triangle X maps onto triangle Z. Triangle X maps onto triangle Z. Describes a rotation of 90 degrees anticlockwise of 90 degrees anticlockwise of 90 degrees anticlockwise about the origin. About the origin. This is how you describe it. Okay? Let me repeat that for everyone. Oh yes, the direction. It's because of 2 marks. When I answer my question based off the weight of the question, Geneva. So normally when I see 3 points, I know I have to mention the direction. So I'm thinking that for this question, I think what they mostly want is the angle and the type. So I'm answering my question based off the weight, but adding the direction won't take away anything from you. All right. So yes, direction is also important. So let me reiterate, guys. Triangle X maps onto triangle Z. describes a rotation of 90 degrees anticlockwise about the origin or from the origin. I want to write it that way, it's up to you. All right, so hope that is clear. All right, if there's anyone that, if there's a question that I'm doing, right? If there's a question that I'm doing on a paper and you've never learned it before, because I have outside students in the class, right? So if there's a topic that I'm teaching or a question I'm doing, and you need to request a particular video that will explain this particular topic, you just have to DM me. One DM and you get the link instead of searching down the whole of my channel. All right, one DM, request the link for a particular video, and you get it instantly, and you can watch it and work on that particular topic.
Okay,
right,
I'm gonna request this topic because I'm not really familiar.
Oh, you're not? Okay.
No.
All right. So just message me after this, Shamir, and I'll send you the link. I'll send you a playlist that contains translation, reflection, rotation, and enlargement.
Okay, thank you.
All right, good. All right, so on the diagram, keyword translate y using the vector -7, 1. Let me discuss this -7, 1, what it means. -7, 1 means that you should, -7, 1 means that you should take 7 steps to your left, because the numbers at the top here represents the x-axis, and this means 1 step up on your y-axis. This number represents the y values. All right, so the top number is the x value, and the bottom number is the y value. And -7 is to my left, and +1 is upwards. So every point that is on triangle y should be moved in that direction. Let's go back to our diagram, -7, 1. Where's triangle y? This one. Let me clean up my diagram here. Clean up my diagram. Clean up. Let me just clean up everything here. It's all messy. So this point here, this one here, should be moved 7 steps to the left and 1 step up. So work with me now. Work with me now, guys. 1, 2, 3, 4, 5, 6, 7, and then up 1. So the position of that particular point that I've circled in blue is going to be right here. All right. Moving on again. For this point over here, I'm going to move that also 7 steps to the left and 1 up. 1, 2, 3, 4, 5, 6, 7, and 1 up. So I'm going to be right at this position right here. And then this point down here is also going to be moved -7, 1. 1, 2, 3, 4, 5, 6, 7, up 1. Right here. So I'm going to use my ruler now, and I'm going to connect these points here. Draw so perfect, guys. You know, the computer screen things there, but lovely. And that is my shape. So that is my new shape. All right. And if you remember earlier when I was trying to explain that whenever a translation takes place, the object and the image are identical in appearance. Do you notice how these two shapes that you're seeing on my screen right now, they are identical in appearance? Anytime you're on a graph paper and you see an object and them say that's the image, and the image and the object look exactly alike, but they're at a different location, confirmation that it's a translation. But if it look like these two over here, to my left, to my right, them, the one, the X and Y, notice how them look opposite to each other? One up, one down, and they're directly over each other perfectly. They're not shift any at all. That's a reflection. And then when you see this one up top, up here, up there, You notice how it looked like it turned? That's a rotation. So even if you're not capable in that moment to get the actual description, just mentioning it, that it's a rotation or a translation or a reflection or an enlargement, you can still steal 1 point out of the 3 or 2 points out of the 3.
Sir.
Still okay. Yeah, G.
The reflection is same as mirror, right?
That's correct. Reflection, same thing as mirror. All right, good. So we are okay then. All right. All right, good. So, it said we should label it with it. Hold on, wait. Don't forget instructions on them to label it V. So please do that. Thank you very much. Please make sure you do that and label it V. For the instruction, people. All right, it says on the diagram on page 10, which is the diagram, you must enlarge, keyword, enlarge the triangle X about from here and use a scale factor half. When the scale factor is a half, can you tell me what this is? If the scale factor is a half, what does that mean?
Well, I'm not sure if you're right, but multiply the image by the scale factor.
That is correct. But what you notice that I use the word enlarge to try to show you off? Because in your mind, you're correct, perfectly correct. You're going to multiply the points by half, multiply the object by a half. But what exactly or what type of enlargement this is? All right. So you see how people, so CXC stay now. That's why when you're explaining stuff to students, it has to be clear. When someone sees the word enlarge, immediately, if I were to run a poll in the chat right now, everybody would think that this thing is getting bigger. When in fact, this is what you call a reduction. Because the scale factor is a half, that means that the image is going to be half the original size. So therefore, the word enlarge in this context does not mean it's getting large, but it actually means that the size of the object is being changed. So very, very key, you understand that. All right, so enlarge in this case means a reduction. So how you know it's a reduction? Because it's half. So can you read off all the points for me, please? For them to the shape what? X. Tell me what the points of X are. X up here. Tell me what all the positions here, here, and here is. Give me the coordinates of those. Read them off for me. What is this one right here?
0, 2.
Correct. 0, 2, sir. That is very correct. Let me go down here and write that 0, 2. Let me just write that 0, 2. All right. What's the next one?
4, 4.
4, 4. Very good, Miss Gentles. 4,
6,
4.
2.
4, 4.
And 6, 2.
And just to confirm it, come now see you see it quickly, but we want to double check. 6, 2.
Man.
6, 2. Good. We just want to see it, man. 6, 2. All right. Now, you're correct, Javar, by saying multiply by a half. But watch your style now. Here's where you're going to get caught. You can't just say a half, times this, They might take off marks. You have to do it like this. You have to say a half, 0, 0, a half. Because the scale factor formula is K, 0, 0, K. So what if I don't do it exactly like that? Will I get some of the marks? Yes, you will, right? Because you're expressing understanding. But in terms of your computation skills, you have to do it like that. All right? Because what you're bringing out here is a little bit of matrices, row by column. So you're going to go row by column. So row by column, row by column, row by column. Then you're going to go row by column, row by column, row by column. Now, you see how I said that and it sounds complicated? You see, even though you're going row by column, row by column, row by column and all that stuff, all you're really doing is just finding half of the number. So through we are bad people, we know exactly what will happen. We're not taking no check from CXC. Half of 0 is 0, half of 2 is 1, half of 4 is 2, half of 4 is 2, half of 6 is 3, half of 2 is 1. We don't take no check. We're not busy with them want say. And that's going to be the answer, and I hit me write down. Who have time to go half times 0 plus 0 times? We don't have time for that. We write down what you want to write down. But we know exactly what the result going to be. Why waste time showing the process of the result? Just get to the result. All right? So hope you are clear on that. Okay? All right. I wouldn't be surprised if they even ask you what type of enlargement.
Sir.
Yes, question.
0 times 2 no 0.
No, man, remember at the half, you use yes or no. I change them. And at the half down here, you used I change them here down here. These zeros here are insignificant.
Okay.
They're just there as a part of the matrix. They have no effect on your answer that's going to be.
They basically not use the 0 them none at all.
None at all. However, you have to put them there because of this thing right here, when them call it enlargement matrix. But it has no bearing on your answer.
All right, then.
All right, cool. Auntie. All right, good. So we're at question 4 now. All right, everybody, checking on everybody. Check in the chat. We do a question 3. I'm gonna check all my people. Let me know. She's on. All right, Aria, Ashley, Avian. On all right, JD. I'm gonna hear your voice now. You okay?
What will the answer come on and say, you're not in my voice?
Oh, I'm never hear your voice.
Sir, you're not gonna
I don't
put
hear
in the
them.
image on the graph
They never ask us to do that.
and label it W.
Oh, we must put it on it?
And label.
Oh, it says,
W.
Okay. So on the diagram on page 10, you must enlarge it. Oh, and scale factor and so you must put it on it. Okay, thank you. My God, we'll only get 1 mark. Thanks, Miss Gentles. So 0, 1. So 0, 1, right? Yeah, so. Thank you, Miss Gentles. My God.
And 2, 2.
And 2, 2, and 3, 1. So 2, 2, and 3, 1. 2, 2, and 3, 1. So this is a reduce in size. So this is what you call a reduction. Thank you, Mr.
Label it, sir, W.
Oh yes, label it too. Thank you very much again. No, we're not correct me today, you know. I like to be corrected, you know. These are genuine mistakes, you know. I'm tired, you know, but you know, I put in the work same way. Alright. Alright, good thing. Alright, checking on my people. Empress, you good? Zahania, Ajir. I hear Shamir voice, Sujani. I don't know who is Samsung. I wonder if that's Samara. Natalia, you okay? No, Natalia, I didn't hear you. No, you're good?
Yes, sir.
Alright, cool. I'm checking. Galia? Ela, you good?
Yes, sir, I'm here.
Alright, that's what I'm checking. I'm checking for everybody after 3 questions. Ashley? Avian? Alright?
Yes, sir.
Alright, let's check in.
Yes, sir.
Stefani? Balance, you okay?
Yes, sir.
Alright. I'm checking. I don't think I miss out anybody. Me and Miss Gentle's voice and everybody good. Empress, is she alright? Jada, is she okay? Gabriel? You're probably asleep.
No, sir, me active.
Oh yeah, I think you're asleep, you know. Alright, so I'm checking for everybody, you know. So alright, cool. So alright, so far. Move to question 4. Remember, even though I'm working questions 1 through to 4, guys, remember the strategy is to do the first 2 or 3, build up some confidence. Don't leave the back part for last. That's a wrong turn. Don't leave the back part for last. All right. You want us to do 2 questions from the back before we come back from lunch? Should I take on 1 question from the back, guys?
Yes, sir.
That will bring fresh now.
Yes, sir.
Everybody in agreement? Yes, take on a question from the back then. So the 3 questions from the front, let's go to the back and see what we can dig up around here. So. Should I take on the vectors or the functions? What should I do? Tell me which one you want me to knock off. You want me to knock out? Take out the vectors from now. I could punch. Could just knock out the vectors and the 1052. Let's knock off the vectors and the matrices and the trig from this section. That could bring fresh, and then we just forward after lunch and deal with the rest of the questions then. All right. Okay, vectors and matrices. Let's go. All right. So switch up brains now, guys. Ready? Calculate the matrix product. Keyword product means that we're going to multiply. So I don't need to say, oh, 2 brackets beside each other multiply. So let me zoom up here for you. No, you see, unlike a while ago when I tell you can skip out and ignore, you can't ignore now. There's no zeros in this one, so you have to show the working out row by column here. All right, row by column here. So let's go. Work with me now, guys. Work with me. Row by first column. Make sure you match first with first and second with second. So 5 times 2 is 10 plus 4 times 0 is 0. So I'm now finished with my first column. I'm still on my first row, but I've just completed my first column. I'm going to move to my second column. I'm going to keep my first row. 5 times 1 is 5. Make sure you first with first, you know. This more time I shout, I beg, you know. Let me say first with first. A second with second. 4 times 3 is 12. All right. I'm finished with my second column. I'm going to go to my final column now. First with first. 5 times -4, -20. Plus 4 times 6, 24. All right. Make sure you do it neater than me. So I'm right here and gully. All right. So now I'm finished with my 3 columns now. I'm going to switch from my my first row now. I'm going to move to my final row, which is down here, and go back to my first column. -3 times 2 is -6. Plus -2 times 0 is 0. Careful now, you know. I'm going to go talk about -2 times 0 is -2. Hey. Can you imagine you doing that? -3 times 1 is -3. Plus -2 times 3 is -6. And then the final one now here is to go down this here. I'm going to have here -3 times -4 is +12. And then -2 times 6 is -12. So -3 times -4 is +12. And 2 times -2 times 6 is -12. All right, check out my matrices multiplication video if you are still having challenges with row by column. 10 plus 0 is 10. 5 plus 12 is 17. -20 plus 4 is not -44, but 4. -6 plus 0 is -6. -3 plus -6 is -9. And 12 minus 12 is 0. And that's the answer. Okay? So the challenge with matrix multiplication is you have every resources that you can watch for I remember when you're watching a video for an hour, you know, but sit down and watch the whole entire class and listen to me explain us the concept. Fast forward up to the part of the video that you need the explanation for the concept for. Don't sit and watch a video. Don't do that. That is you can only watch 24 videos in one day. And if the video is longer than an hour, you can watch less than 24 videos per day. No one has time to sit down for 24 hours doing math. So when you're watching a video, if you're going to watch 3 hours of video, make sure you watch 3 hours of video focusing on the area of the concern that you have. So one time they message me and say, sir, your video them too long. Remember, I'm teaching. So there are other students that have to take in consideration that they have concepts that they don't understand either. So just fast forward up to the part that answers the question that you're trying to answer, the question that you're asking. All right, so that is it for that one. All right, now I'm gonna leave this one to you, and if anybody can tell me what this is, state why the two matrices in AI are conformable. I'm gonna make the big word for you. Why is it allowed? Or why is multiplication allowed? Why is multiplication possible? Can anybody tell me why it's possible? Yes.
Sir, I can't tell you necessarily why it's
Sir.
possible.
Hold on, Jabari. Somebody's first.
Sir, you hearing me?
Yes, I'm hearing you, Galia.
Yes, sir. I can't tell you exactly why it's possible. Well, I can, but I know that in order to work it out, you have to write down the type of matrix, like 2 by 2, 3 by 2, and then if the numbers in the middle are the same, then it would be
good.
Yeah.
Multiple. All right. So we're just a while ago find a very articulate way of writing exactly what you say, and you get your marks. But she's perfectly correct. So what would be the size of matrix 1? 5, 4, -3, -2. What's the size of that one?
2 by 2.
2 by 2.
2 by 2, right? And what is the size of the next matrix here?
2 by 3.
2 by 3. 2 by 3. So students, what Galia was saying a while ago was that after writing down the size of the matrix, right? So the first matrix is 2 by 2, and the second matrix is 2 by 3. Galia was trying to say that if the two numbers in the middle are the same, then multiplication is possible. But if they were different, then multiplication is not possible. Bear in mind, they can ask this question the other way. So they can say, state why the matrices above are not conformable for multiplication. So Galia, I mean, I know how you're going to write that, but you say if you write this here, I think you're going to get the marks. I think if you do this here, you can see that write it how you can write it. Explain. You're a student, so you're obviously not going to explain like a teacher, right? Or how a teacher would. So you find a nice way to explain and say that the numbers in the middle are not the same, therefore multiplication is not possible. I think the examiner will give you the mark. I would give you the mark if I was a marker. All right?
Okay.
But here's the actual explanation. Write this down for me, guys. Matrix multiplication is only possible. Sorry. Yes. Matrix multiplication is only possible. Matrix multiplication is only possible matrix multiplication is only possible if the number of columns on the left, so this will, because remember now guys, this is row, this is row. Whoops, sorry guys, sorry. So this is row, and this is a column, and this is row as a column. So the number of columns on the left is equal to the number of rows on the right. So notice that columns on left is equal to rows on right. Then you're going to end up with a conformable multiplication matrix. All right? Khalil, it's nice to see you. I didn't know you did maths, Khalil. Khalil?
Yes, sir.
Oh, yeah. I remember you. I remember registering you at the school. I know you're still doing chemistry? at MI? Oh, I guess he's probably, I don't know. All right. Anyways, yeah, guys. So that is it. So the number of columns on the left must be equal to the number of rows on the right. All right. So that is the actual mathematical explanation for it. Okay. But like Galia says, she kind of knows how to like put it down on paper, but not word it. So if you're looking to word it, that's how you do it. If not, I think this should suffice. Okay. This should suffice. All right. Now, determine the inverse of 5, 4, -3, -2. We need two components for this, guys. Can somebody recall what the two components are?
The determinant and the adjoint.
Very good, Mr. Cohen. The determinant and the adjoint. Okay. So we need the det. And what's the formula for det?
Sir, AD and CB, or it's BC?
It's BC, but it's not and. It's not
Oh,
and.
subtracted back.
Right. So be careful, because normally what you say is what you write down, you know. So it's AD minus BC. I heard you, Ms. Gentles, correct. So AD minus BC. All right. Now from the matrix here, let's label it. Remember that the first number is A, second number is B, third number is C, and the fourth number is D. All right. So A is 5 based on the labeling, and D is -2, and B is 4, and C is -3. 5 times -2 is -10, and -4 times -3 is +12. So the answer here is equal to +2. -10 plus 12, please use your calculator, ladies and gentle folks. Don't make silly mistakes because you can't be bothered to use the calculator. All right. All right, well, give me a second. All right, back to programming. So we got 2 for determinant. All right, so that's one of the components. The next component is the adjoint, right? So the adjoint. Sir. How do we find the adjoint?
Sir, you flip.
Flip which one? Yeah, to remind me which one you flip.
You change 5 to the -2 spot, -2 to the 5.
Correct.
And then 4 would be -4 and 3 become +3.
Excellent. Very, very good. Very good. All right. And then now to wrap up this inverse thing to get our 2 marks, we're going to see inverse is equal to what?
1 over the det times the adjoint.
Very good, Mr. Cohen. 1 over the det times the thing that the young lady just gave us a while ago, -2, -4, -3, +3, 5. Now, what was the shortcut that I showed you to get to your answer real quickly without wasting time?
So you can put all of the numbers in the matrix over 2?
That is absolutely correct. So we're going to have -2 over 2 We're going to have negative 4 over 2. We're going to have 3 over 2. And then we're going to have 5 over 2. Now, if a fraction can be reduced, people, I don't think you're going to lose the marks for it, but I'd recommend that you reduce it. So negative 2 over 2, cancel. Oops, Lord have mercy, we're gone. Oh dear, oh dear. Where did you go? Okay. All right, good. So if a fraction can be reduced, people, please reduce it. Not that you're going to lose any marks for it, I don't think so. That would be quite brutal for you to take off 1 mark or half a point because I didn't cancel out this and write negative 1. But to be safe, don't take any chances. Cancel out that, you're going to get negative 2. So the inverse of that metric is negative 1, negative 2, 3, 2, 3 over 2, 5 over 2. All right, everybody clear on that?
Yes, sir.
Yes, sir.
Yes.
All right, Geneva. Yes, Geneva. See you in the chat. I see you in the chat, Geneva. See you. All right, so this is the thing that we were explaining in, I think this was what we had explained in our last online contracted class, right? So now we are getting an actual example now. This is your first real CSEC question, right? My day school students, my physical students would have seen this a couple of times as well. Like Safani would have seen this in class as well. A couple other persons as well would have seen this. All right, so let us have a look at this. The diagram below shows triangle OAB. The diagram below shows triangle OAB. Let us find that triangle, please. OAB. Okay, we can see that triangle. Cool, no problem. And it says in which OA is R. We can see the R right here. That's the magnitude. The R is the magnitude. And we are also seeing here where OB is S. That's also the magnitude. So watch now, guys. You see them something here, them little letters right here, so? Those are the magnitude or the length of the vector. That means that from here and here to here, the distance of that line is S. We don't care what S is. We just know that that distance is S. And then the R means now from here to here is R units. You should see, understand what that means. Also, what I want you to do is pay attention to the direction that the arrow is going into. So look at the arrow. This arrow is going this way, and this arrow is going that way. All right? So those are some key things you need to be aware of. Now, this is the part now that plagues students a lot. The part where they give you the biconditional statement. Interpreting that part will make or break you. Interpret it correctly, and you will find vectors your favorite topic. If you have a challenge in interpreting what it means, then you'll find that vectors will break you. All right? Let's interpret what it's saying. It says, in addition, E, the position E, this E right here, is the midpoint of CD. So it is in the middle of the line CD. What does that mean? Interpret what does that mean. If E is in the middle, what does E being in the middle, what does it do to the line CD?
Splits it.
Split it. You can split something in a tree. So be very specific.
In half. Put it in half.
So split in two equal two halves. So that means whatever the distance be, this over here so is equal to this over here so. So whatever this distance work out to be, whatever that distance works out to be, we know say over here so a half of it. And over here so is half of it. Half of CD. That's the interpretation that I beat my students them bad. Right? And that has nothing to do with maths. It just has to do with the English language or the comprehension. All right, so please bear that in mind. Let me just drop on them to something from now. All right, let me drop them on for now. So this here Hold on there. So this side and this side equal. All right. So biconditional statement number 1 interpreted. Next one. O to C. So from O to C is 3/4 of OA. So what that means, people, is that, let me clean this thing up. All right, let me clean this thing up. So what this means now, I'm work with now, guys. All right. So what this means now, you see from here, so watch me now, you know. So from here, so to here, so. Oops, sorry. So from here, so to here, so it is going to be 3/4 of the entire distance. Lock it in now. If they say that O to C is 3/4 OA, that means O to C is 3/4 of the magnitude of the entire line. So the question then is, what is OC? What would I put from here? What would I put? What would be the distance from here to here? What would I put there?
3/4R.
3/4R. Very good. 3/4R. Now here the big question now. What would I put from here to here?
1/4.
Very good. 1/4. Because 3/4 plus a quarter is a whole. So if part of it is 3/4 R, the other part of it be quarter R. I've noticed that I'm working on my interpretation of the question first. I know me not look on what them ask me, say, no. I know me not look on that, because if I look at this down here and I have no idea of what's going on up here, how am I going to answer the question? So when you go on a vectors question, this is what my instructor, my legendary instructor, taught me 17 years ago. Akeen, when you get a vector question, remember to analyze what the biconditional statements are saying, and then you proceed to answer your question. Don't read the question and then say, oh, much hard, I don't understand it, it's too difficult, and I cry. Moving on. The next one says AD is 2/3 AB. So watch me now, you know. See D here, you know. And A to D is 2/3 all of this line. We don't know what that line is yet. So for now, AD is just going to be 2/3 something. We don't know whether something there be yet. But so when time I find this something right here, I can take that something and put it right in here. So now the question is, big question I come now. If A to D is 2/3, what is D to B?
1/3.
So it's 1/3. That something. Now, before me answer the question, is everybody is it understood by everyone?
Yes, sir.
Yes, sir.
Yes, sir.
I need you guys to do this question on the exam, because it's a guaranteed 12 points. It just look hard, but it's guaranteed 12 points. Give me a minute, guys. Give me a minute. Hold on. Give me a minute, guys. All right, my apologies, guys. My screen is now, it's coming back on. Hold on, give me a second. All right. Confirm my screen is sharing, guys?
Yes, sir.
Yes, it is.
All right. All right, lovely. So now, I need conviction. Everybody good with how or what you the explanation of how to interpret these little sections. Once you want to interpret it, watch the magic. Watch the beauty of mathematics now. Once you understand what you're looking at, cakewalk. Watch this. It's like taking candy from a baby. Watch this. CD. What is CD? We need a triangle to get CD. We need to move from C to D. Now remember, vector algebra, as explained in my class, is finding an alternative route to get to your destination without going straight to that point. So if I can't go straight from C to D, where can I go? To get
A
to D.
to D.
I can go from where?
A. C to
No.
A.
Oh.
C
Okay.
to A and A to D.
So I can move from C to A, and then I can go from what? A now back to D. Me still got D, so a D me I try going, it was just me take a different route. So I couldn't go straight from C to D. So me just go, you know what? You what? Take shortcut or take another route. C to A, and then A take me straight to D. Not true? All right, good. How much marks is this work? This is work 2. All right. But we have a challenge now. We have a challenge
Yes,
now, you know.
sir, because we need to write in
In
terms of R and S.
In terms of R and S. But the problem now is we don't have AD. We don't have AD now. We only know something about AD. We know say AD is 2/3 AB, and we don't have AB. So what this is telling me now is that for me to answer this question here, I would have to find AB first. I'm just not good with that, you know. Before I do it, I'm just not good. We already decided that to get from C to D, we have to go from what? C to A and A to D. But we know C to A is a quarter R, we know that. And AD is 2/3 something, but we don't know what that something is. So let us find that something. That something is AB. So AB So let's find out something. AB, give me an alternative route to get to B. Give me a triangle that can take me to B without going straight from A to B.
A.
Go ahead, Jabari. Oh yes, Antoine, correct. A to O plus O to B. All right. So what is A to O now? This is interesting. Let me see if we now focus. What is A to O? Close. Very close, Antoine. A to O. Correct, Geneva. Negative R. So how should you get that? Because we know from the onset, we can't clean up my diagram now, I need these things on the diagram to explain. So let me see if I can highlight something. We know that the entire magnitude of O to A was R, but we are going in the opposing direction. So it's going to be negative R. That is how she got the negative R. And then now notice that O to B now, look now, O to B is going in the same direction you're going in. So that is S. All right, so that is S. So now we find that something there now. Watch me now. So now that we find that something, I can remove my question mark from here and put that something there. So I'm going to move my question mark from here and I'm going to put my something there. So this something right here, so now is going to be negative r plus s. So I can move my question mark from in here, so to and I can put my something in here. And I can also put my something in here as well. All right, good. Now, life easy now. So now that I find that this is the something right here that was preventing me from just getting straight to my answer. Now watch this now. C to D. Watch me now. C to D is going from C to A and A to D. So you notice that I have C to A. C to A is what? A quarter R. Because I'm going in the same direction, quarter R. And A to D is 2/3. That's something. So I can simplify it. I could leave it there if I wanted, but 2 marks. I mean, I waste my time. I don't want to lose no mark because I go too far to lose marks now. So I just want to say a quarter R, right? Minus y minus 2/3 times negative R is negative 2/3 R. So I use the 2/3 and I multiply the negative R. We get negative 2/3 R. And then 2/3 times S gives me 2/3 S.
Find the LCM of quarter R and 2/3 R.
Right, so you're just going to go to sign our workout. A quarter R minus 2/3 R. The LCM is 12. 4 into 12 times 3. 3 into 12 times 4. 3 times 1 is 3. 4 times 2 is 8. So we end up with a nice answer here of negative 5/12. So the answer here is negative 5/12 R plus 2/3 S. And that's the answer. All right. So if you're not clear on this, just when it's posted, which will be posted right after the class, right? Once it's posted, you guys can just watch back the interpretation and catch it back again, all right? So that is your answer right here. All right, clear on that. OE now. O to E. Let's go back on our diagram. Where's O to E? O to E. So to get from O to E, obviously we're going to need a line that goes from O to E. So from O to E, right? That's all? Good. So give me a triangle now that can take me. Give me a triangle now that can take me from O to E.
O to C, C to E.
O to C, C to E. All right, very good. So you're saying, Javar, that if I want to go from here to here, all I have to do is just go from here to here, and then here to here. That's you're saying?
Yes, sir.
All right, go to then, no problem. I like that route there. All right. So I can say that this is OE here. You said it's O to C, and then add back E to C to that. All right, so O to C now. Look at the diagram now.
C to E, sir.
Eh?
C to E, I put E to C.
Oh, C to E. Okay, thank you. Thank you. Where's my marker? Here's my eraser. Thank you. Very good. So it is C to E. Thank you very much. All right, so look at the diagram now. What is O to C? We established that from
the 3/4R.
3/4R. All right. All right, now, big question. What is CE? What is CE?
Antonia
half of
said,
CD?
Yeah.
Half of CD. Very good. Very good, Antonia. Half of CD. Because we did already establish that from day one that E is the midpoint. So from C to E must be half of it. So therefore then, how much marks is it worth? 2 points? Okay. So it's going to be 3/4 r plus half of, all right, half of this, half of that thing over there. So half of -5/12, half of -5/12 r plus 2/3 s. So therefore now, break this up nice and pretty. 3/4 r plus half of this here is going to be -5/24. So it's -5/24. So you get that. 1 times -5, -5. 2 times 12 is 24. So 24r plus half of 2/3 over here. 1 times 2 is 2. 2 times 3 is 6. 1 times 2 is 2. 2 times 3 is 6. So 2/6, which is 1 over, let me see, half of this 2/6. That's 1/3. Look at my marks this still. Alright, so the LCM of this thing over here now, because both of them are, is 24. So 4 into 24 goes 6 times. So 4 into 24 goes 6 times. And 24 into 24 goes 1 time. So when you simplify this now, we're going to end up with 18r minus 5r, which finally works out nicely to be 13/24r plus 1/3 s. All right? And that is your answer. Could I look at more marks? This still is a tough question. It does require you to have some level of knowledge of fractions. I have a lot of vectors to do this still. So 13/24r. All right. So yeah, it's a tough question. Tough in terms of the computation. So I think that for this vector question, the computing part is tough. You're prone to make a mistake if you're not confident with the fractions. But yeah, man, I think you could have do it still. All right. All right. Let's wrap up this now. All right. So the points the point O, Q, and R have coordinates, and we are seeing them 0, 0, 5, 2, -1, 4. 0, 0, -1, 4 up there, so, and 5, 2. You're seeing it. All right. Write down OR as a column vector. OR. So they want you to write the answer as a column. They want you to write the coordinates of R in a column form like that. So what is the position of R? As was told up here. Them say O, 0, 0. Q is 5, 2. And R must be -1, 4. So they gave you in a point form. So they give you -1, 4 in a point form. They want you to turn it into a vector by simply writing as -1, 4. And that's it. That is it. Write it as a column form. That's it.
Explain that again, sir.
Now I'm just saying that up here, they gave you the position of R. Note that instead the points O, Q, and R have coordinate. The points right here, the points, they gave you in a point form when it's written sideways. 0, 5, 2, -1, 4. The question said they want you to write R in a column form. So just take it from -1, 4, like -1, -1, 4, and just write it downwards like that. That's the column form.
Oh,
that's it.
Okay.
Yeah, no calculation needed. That's it. All right, anybody knows what this vertical bar something mean? Or anybody remembers what it means?
The length.
That is correct. The length. Very good. All right. Now, Antonia, I was hoping I didn't catch you, But remember that you don't find determinant of a vector. You find determinant of a matrix. All right. So make a note of that. If they said QR, what would we do?
Find R to Q.
All right. That's a very good question. Check the chat, guys. She's saying that what if they said QR? Well, if they said QR, we just simply turn it backwards and subtract. And we still have to do it anyways. We still have to turn it backwards and subtract. So if they had said determine QR, you still have to turn it backwards and subtract. Because you can't find the length of QR unless you know what the coordinates of QR is. So right now, we have to find QR before we can find the length. So if we go back up here and look for the point for R, remember we said that this is O, this is Q, and this is R. So R is -1, 4. And then we have Q, which we said is, what is this? 5, 2. 5, 2. As -1, -5, that gives us -6. And 4 minus 2 is 2. So that is now QR. But we need to find the length of QR. So to find the length now, we need the square root of x squared plus y squared. So that's the form of a length. Make a note of it, guys. Length of a vector is that thing. It's going to be -6 squared plus 2 squared. When you square -6, you're going to end up with +36. And when you square 2, you're going to end up with 4.
Is this formula on the exam sheet?
Sadly, no. Sadly, it's not.
6.32.
We don't need the answer in a decimal. They've never said that. They said determine the length. So you can just write root 40 units. We don't generally we don't. So if you do that, you're not going to get it wrong. Generally, we don't like when the answers are written like that. If you want to write the answer in a more simplified form, then you could say the square root of 4 times the square root of 10, which is going to be 2 root 10. We rather it like that. Okay. So we can, if you want to break it down, you can break down the 40 into smaller numbers like 4 times 10 and find the square root of 4, you get 2, you get 2 root 10. But if you write 6 point whatever, we don't really like that. Mathematicians, we are not big fans of decimals, right? Decimals are too irrational and it doesn't give any accuracy. Or it gives too much decimal places, which means that the answer is not completely accurate. But when you give the answers like this, you're good to go. All right? And that would be the end of vectors. All right? Not the end of the past paper. Right? Now, based on the fact that the topic that we want to do next, guys, is very, very important, which is trigonometry, I'm going to take the break now and come back at 12:30. All right? Because we need to revive the brain. We'll learn a lot of stuff today. So we do 4 questions so far, right? Questions 1, 2, and 3 there with the vectors. I think that took a lot from me. So I think that a little break right now would suffice. So we'll be back exactly at 12:35 or 12:30 the earlier, maybe give or take 12:45, and we're gonna come back with a bang ready. So get something to eat, no cheese. Get something to eat and drink, and then come back at 12:35. All right. Okay, everyone. All right. You all take care. 12:30.